Here's an example for torque on a loop. And so here we have a circular coil, 18 centimeters in diameter, 12 loops. The Earth's magnetic field at this point is 5.5 times 10 to the minus 5th Teslas, and it's into the Earth at 66 degrees. And if the current in the loop is 7.1 amps clockwise, then we want to determine the torque on the coil and then which edge rises. So if we look at this coil, we know that the Earth's magnetic field is tilted in, so this would be the south side. The other side would be the north side. West is in the back. And east is towards the front. Now, if we figure out our right-hand rule, it's going to take a little bit of a trick to think about. We take and point our fingers in the direction of the current, which is in the clockwise direction, and then through the magnetic field, we see that our force is going to be heading out in this direction. Let's try this again. So I got to think about this. It's clockwise field. So our force is basically in this direction. And this force would be in that direction. So this answers our question as to which side is going to rise up. And due to our forces, this is going to basically pivot on the ground. This is going to want to rise. And so the north side is going to want to rise. Now we can determine the torque on our loop. And so the first thing we need to do is find the area. So the area is going to be of the circle, so we have to find the area based on that. So we have the area is equal to pi r squared, and that's just going to be equal to pi times, well, we have the diameter is 18 centimeters divided by 2 to get the radius, square that, and that gives us an area of 0.025 meters squared. And now the torque of the coil is going to be equal to the number of turns times the current in the coil times the area times the magnetic field times the sine. And now here's the tricky part. The angle that the magnetic field makes with the Earth's surface is 66 degrees. This is not the angle that we need. We need the angle from the magnetic field and the area vector of the surface. So if we make this right triangle, this is 66 degrees here, I'm sorry, this is 66 degrees, and we want to make this 90 here, so that leaves us with 24 degrees. So we actually are doing pi over 2, or 90 degrees, minus our 66 degrees, and that'll be 24 degrees. So it's 12 times 7.10 amps times 0.025 meters squared times 5.5 times 10 to the minus fifth Teslas times sine 24 degrees. And our torque is a whopping 4.85 times 10 to the minus 11th newtons, or meters Newton. I'm sorry, to the fifth. I misspoke. To the fifth meters Newton. That's not millinewtons, that's meters Newton. So that's just a very, very small torque based on the Earth's gravitation, I'm sorry, the Earth's magnetic field and this current flowing through a loop.